Hello everybody, welcome to this lecture, and today we are going to discuss about another parsing technique which is known as simple LR or SLR. Now in our previous videos we have discussed about the LR0 parsing technique, and there we had seen the construction of the LR0 item sets, the construction of the parsing table, then we discussed about the parsing algorithm. Now, all these, when we did all these steps, okay, we also saw that LR0 parsing can have two types of conflicts. That is shift-reduced conflict or reduced conflict. So we had discussed all of this earlier. So the main problem with LR0 parsing was that we did not have any look ahead. That's why it was LR0, no look ahead. So we had to decide whether to shift or to reduce based on the input that we have seen so far. We could not look into the next item, which is, or next symbol appearing in the input string. So the constraints regarding the decision whether to shift or reduce was very tight. So that is why we found also that the set of grammars that LR0 can process is very limited and it is of no practical use. Okay, so if we can just look into one symbol ahead, if we have just one symbol as a look ahead, then our LR0 parsing can be expanded to include more number of grammars, larger set of grammars. So in our SLR or simple SLR parser, this is also known as SLR1. So this one, now you can understand that this indicates a look ahead. So here this is similar to our LR0. It is very similar to LR0, but it uses one look ahead. So as a result, what happens is that our the set of grammars that is accepted can be accepted by, or that can be processed by SLR becomes considerably larger. Now, does that mean that doing our LR0 parsing, studying LR0 parsing is totally useless? Well, it's not, because you see, for SLR, the construction of the LR0 item set, construction or the construction of the parsing table, and the construction of the algorithm or the parsing algorithm is very same. In fact, 1 and 3 is exactly the same, and construction of the parsing table is just slightly different. Okay, so there's a very slight difference between the parsing table construction and in LR0 and SLR1. So that is why when we have done the LR0 parsing, okay, it is not totally useless, because we are going to use these in our SLR parser. Now coming to our conflicts that we had in LR0, you can see that in LR0 the main problem occurred if a particular state, you have a state which has a move like this, alpha dot beta, something like this. Also, if there is a final item. Okay, so if you have a state with two items like this, then this gives rise to a shift. On beta, it moves to another one, but here this is a final item, so you get a shift reduce conflict. Or if suppose I have let me write it here, B gamma dot and C derives, say alpha dot, something like this. I have two final items in a particular state, then I get a reduce conflict. So the main problem is because of the reduce step. Okay, so let us see if we can restrict the number of reduced steps so that we can have we can include more number of grammars in SLR. So as I have mentioned, the difference between SLR parsing and LR0 parsing is the table construction. That is very slight difference. For shift, you have no problem. You can do shift as exactly same as you have in your LR0. That means if I have a production like this, alpha dot A beta, okay, then on A I go to alpha A dot beta. Okay, so this translates to a shift move. So if this is I and this is IJ, then it will be a shift to J on A. And if it is reduced, we have seen also that a reduced item will occur if I have, say, something like this, A equal to alpha dot. So this will be a reduce. This will reduce, reduce based on this is reduce to the production number A derives alpha. So our main assumption in LR0 is that we in every final item, where in any state which is a final item, there must be only one item like this. Okay, I cannot have A derives alpha dot or B derives beta dot. Okay, this is not allowed. Now, is this particular assumption always appropriate? Well, not really, because if we can look at the next token, then it can tell us whether that this particular reduction is valid or not, because sometimes it may not be valid. So suppose I have a production like this, I get something like this, and I also have beta dot. Okay, now whether to reduce by this or to reduce by this, if we can take a look at our input symbol. So suppose I have the next input symbol is A. If I can look at A, and then I can say whether I can have a production like this, whether this is not a production, whether I can have a sentential form like this, say something else is here, something else is here, but whether I should get this or I should get B A. So whether A followed by cap small a or B followed by small b is going to take me to my start state. Which one is valid? First one or second one? Okay. So what do you think that will tell me whether A should small a should come after capital A or small a should come after capital B? Remember, we had done something called the follow set. Okay, in LL1 parsing we did the first set and the follow set. So follow here, if you see, if the follow of A contains small a, then this is valid. But if the follow of B does not contain A, then if I reduce by this particular production, then I can never get B here, because the next symbol is A. I will never be able to reduce to the start symbol, because I'll be stuck here, because B can never be followed by A. So if we look at the next input symbol in the input string, and then we look at the follow of the non-terminal which we are trying to reduce, then we can make a decision whether this reduction is valid or it is not valid. I hope this is clear. So let me just repeat this. If I have a production like this or an item like this, oh sorry, not dot here, alpha dot, B is beta dot. So if in one state I have this is going to give rise to a reduce conflict. Now if I can look into the next input symbol, which is A, and then I check if follow of A, I find out follow of A and follow of B. So if follow of A contains small a, okay, and some more, and follow of B does not contain A, then the reduction which is valid is this one. Okay, I will not use this because in no sentential form I will get B followed by A. This is invalid. But because capital A can be followed by small a, so this particular reduction is valid. So what we are going to do, we are going to find out the follow set. So in the parsing table, if you remember, when I have a state like this, and here I have, say, the terminal symbols, okay, in LR0, whenever there was a reduce step, okay, suppose in state 3 there is a reduce item, then I will get, here I say reduce by production 2, I'd give reduce in all the entries for all the columns of all the terminal symbols, okay. But in SLR we are not going to do that. In SLR what we are going to do is, we are trying to find out, suppose we get a reduce move, okay, for a production A derives alpha. This is how we are going to this is the reduce that we are going to do, and we find out what is the follow of A. And then only in those items, suppose follow of, say, let me say we have three non-terminals A, B and C, and say follow of A contains A and C. So instead of writing the reduce and they say this is production number 2, so instead of reduction of R2 in all the columns, we will write only in this. So the chance of having a reduce or shift reduce conflicts becomes much lesser here. So this is your SLR parser. So only this part is different. Instead of writing the reduce move in all the columns for a particular state, what you are going to do is, you are going to write only in the follow of that particular state, not the state of that particular non-terminal. So only under those you are going to put a reduce move. So let's take this example. So here I have an augmented grammar. This is our expression grammar that we had seen earlier. And here we have constructed the follow set of all the non-terminal symbols. Basically, you don't need much. You don't need for follow of E dash of the augmented start symbol, but for the rest we have already computed. So we have already seen how to compute follow of a non-terminal. You can view the video for it. So here this is the partial diagram for our DFA. So here you can see this is what we started from. This is I0. Say let's call this I1, I2, I3 and I4. Okay. So I0 on E goes to I1, and here you can see there are two productions here. One is on E, I0, the dot moves here, so you got E dot. Similarly, here from here also, when there is a E here, so the dot will move to the next, so E dot plus T. E dot plus T. So if you see in this state I2, you have one reduce, this is a reduce, whereas this is a shift. This is a shift move. So in our LR0 parsing, this would have created a shift reduce conflict. Similarly, in the second state, that is I2, you can see this is a reduce move, okay, on T, On T, there are two productions where the dot is before the T. So when you get a T, it moves, the dot can move here. So E derives T dot, and similarly T comes here because of this particular item. So here also I have a reduce as well as I have a shift. Okay. And for the others, I3 and I4 states, these are single item sets, and both are final items, so we don't have any problem. So let us just write. I'm not expanding the rest of the states because it's the same method as in LR0. So we'll try to write the parsing table for these states. So I0, I1, I2 up to I4. So I0, I1, I2 and up to I4. So I0, you can see on ID it goes to I4. On ID goes to I4. So shift 4. And go to, on E it goes to I1, on T it goes to I2, and F it goes to I3. So 1, 2 and 3. Next, for state I1. For state I1, if you see, this has got a reduce as well as it has a shift. So since this is the reduce for your E dash, that is reduce to E dash, so we will put in dollar. So we'll say except in dollar. Except in dollar. But there is also a shift. So there is also a shift. So shift on plus, shift. So we'll find what is in the follow of what is there here. On plus, we'll give shift to some, we don't know where it is going to go. It is going to go on plus, it is going to shift to some other state. So it is going to shift, the shift move we will put on plus, because the next item is plus. So on plus, this is going to move to an item containing E derives E plus dot T. Okay, there may be some more items. So it will shift to, let's call it 5. Say this is state I5. So it goes to 5. Next, for state 2, I2, that is this one, again you have two reduce, one reduce and one shift. So E derives T dot. So instead of putting reduce in all the steps, in all the columns, that is in all the columns, we are going to put reduce only in the follow of E. So follow of E is plus and dollar. So we will put reduce in plus and dollar. So plus and dollar. This is where we are going to put the reduce. Now reduce to what? This is our production number. Let's call it, this is 1, this is 2, 3, 4 and 5. So we'll say this is reduce to 2. So reduce to, reduce to, reduce to. Otherwise we would have put in all the columns in LR0. Now, so now here I have, this is also a shift. This is a shift on star. The shift can be on star. So on star, it may shift to some other state. Let us call it say state number, this is 5. Let me call it state number 6. So on star, it will shift to 6. So as you can see in this particular example, there is no shift reduce conflict for this statement. And for the others, for the next one, that is for your state I3. I3 is a reduce. This is a reduce. Since it is the only one, here also it is a reduce. It's the only one. So no problem. So this T derives F is number 4 and F derives ID is 5. So for 3 it is reduce 3 or reduce 4, sorry, reduce 4, reduce 4, reduce 4, reduce 4. Okay, and for 4 it is reduce 5, reduce 5, reduce 5, reduce 5. Okay, so if a particular state contains only one final item, then you write in all the columns. But if it contains more than one, then you put the reduce move only under the columns which are in follow of, say, whatever is the reduction you are using, follow of the reduction symbol. So in the same manner, now you can construct the rest of the table. The go-to part remains exactly same. There is no change in the go-to part. So this is about SLR parsing. So you have seen that as a result of making the small change as to where to put the reduce, restricting the number of places where we can put the reduce, it also eliminates a number of conflicts that may have occurred, reduce or shift reduce conflicts. Okay, and as a result, SLR1 can contain, or it can handle a larger set of grammars as compared to LR0.